Hi everyone! Today we're going to be taking a closer look at a specific type of pattern folding problem, and that would be problems involving cube structures. Cube problems can come in a variety of different flavors. They can have different orientations of maps, some have shaded patterns or symbols, and some even have unique extra faces like these. Cube problems are under the category of regular prisms with shaded patterns that we mentioned in our previous video. We're going to be discussing how to approach these problems and tackle them systematically. So that way you can answer any cube problem that comes your way on your exam. First, in order to answer these questions, you have to know how different arrangements of maps will come together to form cubes. So that way you'll know which faces border each other and be able to determine their orientations. So let's go through these general map types and see how they fold. Let's start with the classic DAT map, which is like the original map layout tested on the DAT. A map like this is really nice because it's symmetrical, so it's easy to see how everything is going to connect. So for instance, for a map like this, you can tell that this top edge and this whole center column folds around the cube in a straight line. See how these sides are arranged in a straight row around the cube? And then these faces fold down onto opposite sides of the cube. With that established, let's look at which face borders will end up connecting. We already said that this top edge will end up connected to the bottom edge. And then for these maps, you also want to look for a starting point where there are adjacent borders, because you can tell really easily that adjacent borders are going to connect to one another. For instance, these adjacent borders will connect, as will these adjacent borders. And then that leaves these edges connecting to this bottom face. And here's a folded map that shows these edges coming together. And you can see again in these maps how the middle faces wrap around the side faces. But that's just one kind of map layout. There are a lot of variations of maps, like these two, where you once again have the same row of 4 faces that then have an additional face on either side. Whether these are oriented vertically or horizontally, they will always fold so that the ends of these rows come together. And notice that the squares on either side once again form opposite sides of the cube. So with these kinds of layouts, let's look at which edges come together. We know that these faces marked in purple form opposite sides of the cube, and the other 4 faces wrap around them. So let's look at this face at the top. These 2 adjacent faces will border it here, so that means that this face would have to border the top edge. For the bottom face, this face already borders here. Then this face would border here, because these edges are adjacent. This face would border here, and this face must wrap around to this side. Again, notice how these edges wrap around the 6 at the bottom. But if you're still not sure how the 2 would orient, you could always notice that on the side that borders the 6, the dot should be next to the face that has the 5. Noticing details like that will really help you keep track of things. Lastly, let's look at a more complicated map without a straight line of faces. If you get a map like this where you're not sure how it folds, then it can be easiest to just start at adjacent edges and work your way out to see what connects. We know that these 2 must connect, and these must connect, and these must connect, since these are all nice adjacent edges. And next, work your way out consecutively to more distant edges. At the top, these edges flank 2 of those adjacent edges we just talked about, so they must connect. And at the bottom, it's the same. These flank 2 adjacent edges, so they have to connect. And we just keep working our way out, looking for the next set of edges. That leaves these edges connecting, and these edges connecting. This is the best way to go about analyzing a cube map that's just a little bit too complex. You just start with adjacent edges and work your way out to see which faces connect. Now, on real cube problems, we want to use what we've learned to look at which faces connect to each other and the orientations of the patterns, but we don't have to visualize every single connection or every way the pattern is oriented, or else we'll get really overwhelmed. So when I approach a cube problem, I like to see if there's anything I can notice that can help me eliminate answer choices quickly. Specifically, for a problem like this with unique faces, we can look at pairs that must sit on opposite sides of the cube, like these 2 faces these two faces, and these two faces, which sit on the left and right. So just by noticing that simple detail, we can eliminate choice A because it shows the F face and the D face sitting right next to each other. And actually choice B because it shows the A and the C sitting right next to each other. So that gets us down to two answer choices. Choice C shows the D, E, and C faces all sort of clustered together, which is actually correct. And choice D shows the A, D, and E faces all clustered together, which is actually also correct. So we're going to have to look a little closer at the orientation of the letters, which is what you'll have to do for any kind of symbol that's on a cube like this. So if we look at choice C, we can see that the D face sits properly on top of the E face, aligned vertically over here. And then the C sits to the right of the D face. See how it shows D and then C when you read it from left to right when they're arranged this way? So choice C looks correct. Now if we look at choice D on the other hand, we see the A and the D aligned vertically, where they should be aligned left to right. And we see that the AE position is wrong as well. Notice that the bottom of the A should fold down and actually border the long edge of the E. So with that, we can eliminate choice D. And choice C is our answer. Let's look at another example that still uses letters, but where we can't really eliminate answer choices right off the bat, but instead have to go straight to looking at the different orientations of the symbols. We can tell that when this map folds, this face will attach to this face, so that these four faces will wrap around these two faces on the ends. Knowing this, let's go through the answer choices. Choice A does show the X, Y, and Z all clustered together, meeting at this one corner, which matches what's seen in the map. However, let's look at how they're oriented. It's most clear to me that the X and the Y are oriented the same way if you read them from left to right on the map, which doesn't look like it matches the cube in choice A, because choice A shows them oriented on top of each other vertically. And the Z looks like it borders at the bottom of the Y, like this, and the bottom of the X like this. Not like this where it's oriented on the other sides. So we can eliminate choice A. Choice B shows the Z face bordering the bottom of the Y, but it borders it on this long side instead of on the short side like it is in the map. So we can actually eliminate choice B also. Choice C shows the Z face bordering two of the blank faces. And this seems to fit these two blank faces that are on the map. They have adjacent borders that must come together. And this face on the left should also wrap around the Z face. So it sits at the bottom of the Z here. So that matches the map. We could pick C as our correct answer right now, but let's see why D is incorrect. Here we see the Y on the left of the X when they're facing this way on the map, and it would look like this if it were folded, where they're facing the same direction. You might think this matches D pretty well, but in choice D, they're actually flipped around facing the other direction. So this should result in their orientation being inverted, so that the X is on the left. And you can see how this would happen if you imagine the map turned upside down. Choice D shows them sitting in the wrong order. So we can eliminate choice D, and choice C is our answer. Okay, let's look at a problem where the cube has a shaded pattern instead of symbols like letters. These problems come up a lot on the DAT. And here we also have a map that's a little harder to interpret. For a map like this, you'll want to remember that adjacent edges, like this, will always come together. And then you can kind of work your way out from there and see what other edges connect. Like this one must connect, and this one must connect, and these ones on opposite sides will also come together. You don't have to spend too much time analyzing this, but you can use this knowledge if you need it while you're reviewing answer choices. When I look at a problem like this, I try and pick out things that stand out to me to see if they can help me make any quick eliminations. For instance, with this map, I see that there is a shaded square right smack in the middle of this center face, and this face with the square borders the half-shaded face on the blank side. I can right away see that choice A shows the shaded square sitting too far away from the center, so I can just eliminate that. And choice D shows the shaded half of this face bordering the face with the square, so I can eliminate that choice as well. That leaves us with B and C, which look about the same, except for the orientations of the blank and shaded faces. Looking more closely, this corner here must match this corner here, because that's where you have a shaded face meeting a blank face, both bordering the face with the square. Choice B shows that when the blank face is at the top, the shaded face is on the left, and this matches what is shown in the map. This is easier to see if you rotate the map or turn your own head to see it from a more comparable angle. So B looks like it's correct. And then choice C, on the other hand, shows that when the blank face is at the top, the shaded face is on the right, which is incorrect. So we can eliminate C, and B is our answer. Next, let's look at a cube that has more than one half-shaded side, because these also come up a lot. As usual, I'm going to see if anything about this map stands out to me and can help me eliminate a wrong answer. First, I can see that there are 3 faces that are half-shaded, all lined up in a row. Because they're in a row, and will fold like this, I know that they can't all 3 be visible from the same view. So I can actually eliminate choice D, because it shows all 3 clustered together. Next, I'll see how each of these shaded rectangles are oriented in relation to one another. I see that they're all parallel in the way that they're facing, and they'll actually stay parallel after they fold, which means I can actually eliminate choice A because it shows these shaded rectangles sitting perpendicular to one another. I can also see that the shaded rectangles are either bordering one another or separated by just one similarly sized blank rectangle. And this helps me eliminate choice B, which shows 2 blank rectangles in between 2 shaded rectangles. So we actually just eliminated all the wrong answers based on some really simple observations. This leaves our answer, choice C. But let's go through it just for the heck of it. Choice C shows the 2 shaded rectangles separated by 1 blank rectangle. Notice how the rectangle should be oriented like this if this blank is at the top. And this is easier to see if the map is flipped like this, which you can do in your head. So C is, in fact, our correct answer. Let's cover a dice problem next, because these also come up pretty frequently on the DAT. Sometimes on these dice problems, they have some really easy giveaways, like this dot being in the completely wrong spot, and this 3 dotted side being turned really obviously, that we see here in this problem from our ADA explanations. But in this problem, I don't see anything so obvious about the positioning of the dots here. I do, however, want to look at which faces will end up on opposite sides of the cube from one another. In this problem, that would be the 6 and the 3, the 4 and the 5, and the 1 and the 2. And this helps us eliminate choice C, which shows the 4 and the 5 sitting next to one another. From there, I have to look a little bit closer at the rest of the answer choices, looking to see which faces sit on the left or the right, for instance, and also if the orientation of those symbols is correct. Choice A shows a 6 on the left and a 5 on the right, when the 1 face is at the top. But the map shows that the 5 should actually be on the left, and the 6 should be on the right, when the 1 is at the top. So A can't be correct. Choice B shows that the face with 3 dots and the face with 2 dots both border the face with 5 dots. This is true according to the map. So let's check their orientation. It looks like the 3 should be on the left and the 2 should be on the right when the 5 is at the top. Notice how the orientation changes when you flip the map upside down. So this looks correct. It also looks like the individual dots are in the correct orientation. Notice that on the 2 face, the top dot, which sits closest to the 5, also sits farthest from the 3. And on the 3 dotted face, the dot that borders the 5 also sits closest to the 2 dot face. So B looks good to me. Choice D, on the other hand, correctly shows that the 1, 4, and 6 all border each other. But it's easy to notice that the 6's dots are arranged incorrectly. The map shows them running parallel to the edge bordering the 4 face, and perpendicular to the edge bordering the 1 face, which is not what we see in choice D. So we can eliminate D, and B is our correct answer. Alright, let's do one more example. This time it's going to be a really hard cube problem that a lot of our students miss. This problem looks like it has a lot going on. And there isn't anything simple that stands out that I can look for in the answer choices. So I'm going to just look over the answer choices and pick out something to focus on. So one thing I notice is that every single answer choice includes this face that has this hourglass pattern on it. So I'm going to focus on this and see how the other faces are oriented around it. Notice that all the faces around this hourglass shape are half shaded along their diagonals. So they each consist of one shaded triangle and one blank triangle. So keeping this in mind, let's look at choice A. It shows two blank triangles bordering the hourglass face. However, you can see on the map that only the blank triangle on this face borders the hourglass. For all the other faces, it's their shaded triangle that's bordering the hourglass face. So we can already eliminate choice A. Let's look at choice B next. Choice B shows the base of the hourglass bordering a blank triangle. So as we discussed just a minute ago, that has to be this triangle. Choice B also corresponds to the correct positioning of the shaded triangle in this face. Notice that it should sit in the lower left corner when it's turned this way. This means that the face at the top of choice B must be this face. And choice B correctly shows that this triangle borders the hourglass on its blank side. Notice that it also shows a shaded triangle in the bottom right corner of the face in this position, which matches things in this orientation. So overall, this looks pretty good, but let's still check the other answers. In choice C, I'm seeing that it shows two shaded triangles coming together, like these two on the map. But if you were to orient them at the top and right of the hourglass face, as they are in choice C, you'd end up with an hourglass that's actually facing the other way. This is a little easier to see if you turn your head to rotate the map like this. So we can eliminate choice C. Lastly, choice D shows a shaded triangle bordering the base of the hourglass. So that would have to be this triangle, but that means that the face to the left of it would be this face, which would meet it at this point. And it wouldn't look like the triangle seen in choice D. It's oriented the wrong way. For choice D, it would look more something like this. So we can eliminate choice D, and choice B is our answer. Alright, here's a recap of our tips on how to master cube folding problems. First, make sure you understand how these maps fold. Maps with 4 faces in a row will always fold so that those 4 faces wrap around the cube in a row. And they'll be wrapping around the faces that sit on each side. This is always the case no matter where these side faces sit. If you're not sure about the connections that'll form between faces, start by looking at adjacent edges, and then work your way out from there. This can really help with complicated maps where you're unsure of how they fold. Start with adjacent edges, and work your way out from there to see which faces connect. Don't get overwhelmed by trying to understand exactly how every face comes together. Instead, follow a systematic approach to the problem. First, look for things that stand out to you in the map that could help you eliminate answer choices quickly. This could be looking at which faces will sit on opposite sides of the cube from one another, and eliminate answer choices that show 2 of these faces sitting next to each other. This could be looking for clear and obvious pattern orientations. For instance, seeing that all of these shaded rectangles are parallel, and eliminating answers quickly based on that. Or looking at the spacing between these rectangles, and eliminating answer choices based on that. After looking at the map, go through answer choices sequentially, looking for the correct positioning of faces and orientation of their patterns. You want to make sure that faces sit on the correct side of the cube in relation to one another. And you want to make sure that their patterns are oriented correctly in relation to one another. This could be symbols pointing in the correct direction, or shaded patterns lining up correctly in relation to one another. For really complex problems, it can be helpful to focus on the orientation around a face that multiple answer choices have in common. Hopefully, this helped you better understand how to approach folding cubes in the pattern folding section. We have lots of diverse cube problems in our question banks, so study these carefully and make sure you understand the reasoning behind the correct answer and the wrong answers. Good luck studying, and look out for our next video.